Hello, my dear students. Welcome to my YouTube channel. In this video series, I am going to solve numerical problems from the second PUC physics chapters. Okay, so I am going to start with the first chapter, that is electric charges and fields. I will try to cover all important concepts from all chapters. So first of all, let me start with electric charges and fields. So in this, the first question is calculate the number of electrons required to make minus 1 coulomb of charge. This is very easy. So we have this formula, Q is equal to N into E. So here the data given is Q is equal to minus 1 coulomb. See, if you want to solve any question easily, any numerical question easily, you should have the basic theory idea about that particular concept. Okay, then only it will be easy. So we know what is E value, that is 1.6 into 10 to the power minus 19 coulomb. So what do you need to find? The number of electrons. Number of electrons is represented by N. Simple. So now Q value is minus 1 coulomb, that is equal to N. We have to find E value is 1.6 into 10 to the power minus 19 coulomb. Here this unit coulomb will cancel with this one on both sides, so we will left with minus. Actually here it is the charge of the electron, we can consider minus N. Minus will cancel out, so even though if it is not there, we cancel minus N because N is we take the magnitude because N cannot be negative here. So then 1 is equal to N into 1.6 into 10 to the power minus 19 coulomb. So then if you solve for N, you will get N is equal to 1 divided by 1.6 into 10 to the power minus 19, and that gives 6.25 into 10 to the power somewhere around 18. Yeah, that's it. So N is equal to, you can write like this, 625 into 10 to the power 16 electrons. So this is the number of electrons required to make minus 1 coulomb of charge. Even if you want to calculate for 1 coulomb of charge, you will get the same number of electrons. Okay, so then if you want 2, you have to substitute here 2 coulomb. Here 5, just substitute Q value as 5. Okay, so clear with this? Thank you. So in the same manner, we have one more question, that is how many electrons will make 1 millicoulomb of charge? Okay, so similarly QL is given 1 millicoulomb. What does it mean? 10 to the power minus 3 coulomb of charge, and E we know that is 1.6 into 10 to the power minus 19 coulomb. And what do we need to find out? N value, that is how much. Okay, let me substitute all the data which is given here in this equation. So we'll get 10 to the power minus 3 is Q value, that is equal to N value we don't know, and E is 1.6 into 10 to the power minus 19 coulomb. Okay, here also we'll be having coulomb, so this coulomb will cancel out this one, and then we have 10 to the power minus 3 is equal to N into 1.6 into 10 to the power minus 19. Okay, so then we can solve this easily. So N, if you want to calculate, you will get 10 to the power minus 3 divided by 1.6 into 10 to the power minus 19. So then if we solve for this, we know 1 divided by 1.6 into 10 to the power minus 19 is, you will get 1 divided by 1.6 is 0.625, and if this denominator 10 to the power minus 19 comes to the numerator, it will get positive sign here, that is plus 19 into 10 to the power minus 3. Okay, and then if you solve for this, 0.625 into 10 to the power plus 19 minus 3 will give you how much? 10 to the power 16. Okay, so plus 16, that is equal to 6.25 into 10 to the power 15. So this is the value of M. So I think this one is clear to you all. So that's it. Thank you. Okay, we have one more problem here. If a body gives out 10 to the power 9 electrons every second, how much time required to get a total charge of 1 coulomb from it? Okay, simple. So according to this, we can get the data, that is 10 to the power 9 electrons every second. So it takes 1 second of time for 10 to the power 9 electrons to come out of a body. 10 to the power 9 electrons in 1 second. So for each electron, how much time does it take? 10 to the power 9 second. Okay, clear with that? So now they're asking how much time does it take for 1 coulomb of charge. So 1 coulomb of charge means how many electrons? 6.25 into 10 to the power 18 electrons that we have already studied. So how much time does it take for these many electrons to come out of a body? Or in how much time does that body gives these electrons? Simple, you just multiply this time with these electrons, because for one electron this much time, for these many electrons into this much time. So that is 6.25 into 10 to the power 18 electrons into given time, that is 1 divided by 10 to the power 9 second time for this many electrons. So that gives you 6.25 into 10 to the power 18 minus 9 will give you plus 9 second. So this is the time. So t is equal to 6.25 into 10 to the power 9 second of time required for these many electrons to come out of a body. Simple is that. So this is second, this is in seconds. We can convert this one to minute, we can convert this one to hour, we can convert this one to day as well as year. Let me convert this time to years. Okay, so t is equal to 6.25 into 10 to the power 9 divided by 60 minute or divided by 60. This can be converted into hours also, or days divided by 24, or 365. Okay, this will be in year, so total time period can be converted into years by this method. So that gives you how much? 198.18 year. So that means it takes for this body to give out these many electrons how much? 190.18 years. This is the answer. Thank you. Okay, dear students, we have one more problem here. It is similar to the previous one. So if possible, try to do it by your own, and after that you can cross check the answer with this. So the question is 10 to the power 19 electrons are removed from a body every second. So what will be the charge on the body after 10 to the power 9 second? Very easy problem. Let me solve this. So according to this question, 10 to the power 19 electrons are removed in 1 second. But what we need to find? We need to find a charge. So let's convert this electron to charge Q. So that means, so these many electrons constitute how much charge? So that can be calculated by 10 to the power 9 electrons will be converted into coulomb by dividing, okay, 6.25 into 10 to the power 18. So this will be converted into coulomb. So that will give the value of these electrons in charge. So that will be given as 1.6 into 10 to the power minus 19. This value 1 divided by 6.25 into 10 to the power 18 electron value is 1.6 into 10 to the power minus 19 into this 10 to the power plus 19 as it is in 1 second. You can solve this by using calculator. So this two will cancel out. You will get 1.6 in coulomb in 1 second. That means 1.6 coulomb of charge is removed in 1 second. But we need to find out the how much charge is removed in 10 to the power 9 second, isn't it? So just multiply 10 to the power 9 on both side. Coulomb will give you 10 to the power 9 second. That means in 10 to the power 9 seconds, this much charge will be removed. That means in 10 to the power 9 second, this much charge will be removed. Okay, so that's all about this question. Simple one, you can do it by your own.